Hello again, and we are back with a water damaged ECU. It's fairly common. I do end up doing a lot of them. Not so much now that the E90 isn't sort of as common as they used to be, but still, yeah, when you get sort of rainy weather, a week later, then these will start turning up. So what happens on these? This one is a 3 series. 3 series are the most common to have these issues. 5 series and 1 series, they could technically have the same kind of thing, but the 3 series has a bit of a design flaw that kind of causes this. So rain will run down the windscreen, and it'll go behind the suspension strut and underneath the ECU box, and there should be drains there to let the water out. But quite often leaves and rubbish and all sorts of other crap might get underneath it and block the drains, and then when the water builds up, it will fill the space on the outside of the box, and then because these boxes have a drain, the water then comes in through the drain into the ECU box and floods them. So this one, if we can see there, we do have a bit of a tide line, and this sort of a darkened colour down here, that there is from the water. So this would have been sitting in about an inch of water at the bottom, as they do sit like that. 335D. The customer has a remap on this one, so the idea is then we'll try and save the data out of this, clone it into a new one, and then it should be just plug it straight in and go. So we're going to have a look now. The first thing we're going to do is see if this will communicate, and see if it's still alive, and see if we can get any information out of it. That's him now hooked up with Flex. So with Flex and this bench mode, it gives you all the connections you need to make. Constant power and ground, switched ignition, K-line for communication, and then these two wires, which activate some tricky clever mode, ends up being the cam and the crank signal. How this works, I've no idea, but it sort of generally unlocks a lot of this stuff, and you can do reads of the complete EEPROM, the flash file, the processor, and all that kind of stuff. So we're going to give this a shot now and see if this will read it. Not supported. So that means generally it hasn't communicated to anything. So let's just try now and see if we get anything on just like a regular INPA lead. So if you have Flex, this is a good lead to have. This is showing us Flex 2.14. I believe that's the name of this thing. Hopefully that's not just the molding name of the plug. This plugs into your Flex box with an OBD port, and you can use this then as pretty much a breakout box for these ECUs. So we're still using the same connections we had before. We can power this thing up, and there it is, that's powered on. And we'll go and have a look now and see if INPA will do anything. So 6-cylinder Bosch with DDE6 for M57 top, and it's thinking, and no. Right, so this thing is functionally dead at the moment. So what we will have to do is go inside and have a look and see what we can do from there. There's our lid off now. If you are removing these, 6 screws around the outside, and watch out for this then, which is a strip of glue. You'll see him over there. You will need to pull from this side, and just with a decent bit of torque, pulling on that, and just let it sort of slowly pull off by itself, and it will come off. Be careful if you're going to be using screwdrivers on them. You can get a bit of leverage on them, but remember, if you are levering in, lever that way so the tip of your screwdriver hits the back of this metal plate, because if you stick in something and you go that way, you're scratching this all over the board, and making a real big mess there of all sorts of other bits and pieces. So we'll get a bit of a closer look now into this. So yeah, as we can say, there's a tide line down the bottom, so that's been sitting in inch and a half of water at least, and we can see then a fair bit of corrosion on various other components here all down the bottom. And also this here, which is our BDM port, if I just poke to this thing. So this port would have been able to connect direct into the processor and then get the processor to go and give us details about all of the memory chips that are inside of this. Because this is, well, we'll give it a shot and see what happens, but I think a lot of this stuff is going to be too corroded for it to work. There's a closer look at the BDM port. Some of these connections here are going to be data. There is also a 12 volts and a 5 volt, and quite often you will see that the ones with power on them, they corrode out very quickly. There's some kind of electrical thing, you know, when you have water and something with voltage on, they're the ones that will rust first as the electricity does something. I guess it's galvanic corrosion. So we'll give this a bit of a clean. We'll try it on the BDM rig. I don't have much hope for it, but we'll give it a shot, because that would be, I suppose, one of the next common steps in terms of like the easiest way of recovering these. And this now is the BDM rig. So what we have is a connection of pins up the back that will interface onto those pads that we have, and it goes off here to the FG Tech Galetto. That's connected into my laptop now. We have a power switch up here which switches power on and off into the ECU, but I don't see any difference in amp draw, so I have a feeling that's doing absolutely nothing. So we'll have a quick look. Let me just get my laptop open. We're in our BDM setup. We have the right driver selected, so we'll hit connect and we'll see what happens. No. So that one, error, micro not supported, turn ignition off and wait 10 seconds. In other words, we tried to communicate and nothing happened. So it's guessing like maybe you've got something that doesn't talk or whatever. But yeah, this one looks like there's no way of reading through the bench, through OBD like it was in the car, or even direct into the processor. So dead to the outside world. What we need to do is go in deeper again and get to the memory chips. There's our pad now on the microscope, and yeah, we can see this pad here. I'm guessing that's going to be the 12 volts. It would have come from that little wire just there. He's completely corroded away. And no. So I gave that a bit of a rub with the soldering iron, and wow, that is pretty big. Let's find something smaller to point at it with. There we go. So our little wire that was at the top there, yeah, there's nothing left really of that. So as I gave it a rub, I was hoping I might catch a bit of solder onto there and drag it over onto where this pad used to be, but no, he's off. So there we go. If I can show him, yeah, there's nothing there at all. So we're going to go for the old-fashioned way now, the nuclear option. We're going to get the chips off. He's out now. So to get them out again, you've got more glue strips. You can see them there and there. What you will do is just leave it gently up at the side. Don't go too crazy because you don't want to flex this board too much. But you're going a little screwdriver there, a little bit of a lift, little bit of a lift, little bit of lift, and it will slowly peel up and come out. So once we get into here, we can see Yeah, there's damp got all the way up to the top around there, but certainly things like that, look at the state of that. That's going to be part of the big problems. So anyway, this over here, where is he? There he is. This is the main flash chip that we need to save. His legs are a little bit corroded there, but I'm sure we'll get him out and we'll get him saved. And there is also, again, an EEPROM. Where is he? There he is. That's an EEPROM. So he's going to have injector codes, rolling codes for the immobilizer. The flash chip on the other side is going to have the main program. That's going to have whatever tuning is on there. It's going to have the seed key for our immobilizer. So it uses a seed key to generate rolling codes. The rolling codes are in here, the seed keys on the other side. This is our processor, ball grid array. So he's on a whole bunch of tiny little solder pads underneath. That's probably why you don't want to flex these boards too much, because if you flex them, you can end up cracking a lot of these solder joints underneath and making a real mess of that. But this one here anyway, the ECU, it's dead. It's pretty much given up on it. It is just going to be a case of saving the chip. So the EEPROM on the far side, our flash chip on this one. And what I'm going to do for this particular one is I'm going to go and transplant that flash chip into another ECU. Now it doesn't have to be the right ECU, just anything where it'll interface through to our Motorola 555 processor through one of these where the BDM pads are all in place. So it's going to go BDM into processor, get the processor then to read out the contents of that flash chip. Then I've got a copy of that, and we can also transplant this chip as well, and then that data can be put into a a new ECU, which we're going to clone it into. But doing it that way will mean the new ECU, I won't need to break him out of the glue and so on. So it just avoids a step, a risky step of opening these things up. So on this one, as I said, it's dead. It's game over. Our final mission is just to save that one particular chip. So we're going to do that. But on the new ECU, the clone that we'll have to sort out for this thing, we don't want to go too much into flexing stuff around because we don't want to break the new ECU. So if it's a step we can avoid, we're going to avoid it. Also, just here, in fact, this is the atmospheric pressure sensor. These do sometimes show up faulty, but again, these are the kind of things that they're not very happy if you get them damp. So this one, because we got water inside of it, he's going to be screwed. So there's a lot of other, you can see the amount of stuff that we have around here. If I zoom into that, yeah, there's a lot of stuff there that's all going to be sort of screwed up. A lot of corrosion over here as well. You could have a shot, sort of cleaning this stuff up, but with some of the traces I've seen that have already burnt themselves out and corroded away, it's not really worth your time fighting through in these things. So next thing to do then, we'll get these chips off. Right, got the hot air soldering iron out, so we're going to heat this fella up and lift him up. This one is going to be a little bit more awkward than some of the other ones because we do have legs on 4 sides. So it's not like we could just heat up this side, lift him up, then release the other, because we still have the legs on this side and this side holding him down. But what I'm going to do is we'll get a bit of heat into him first, then start concentrating on certain sides to lift those sides up, and I'm going to give it a little bit of prying up in each one of these corners to see when we get it going. And I'm also just going to shut up now because I'm going to fast forward through some of this stuff, and you don't want to hear weird noises as it speeds up me talking. And there we go. So that's him up. You can see traces of corrosion underneath and so on, but these chips, they normally do pretty well. As long as we get data out of it, that's all that kind of matters in this particular case. But because they don't particularly run high current, they're not on 12 volts or anything like that, they do tend to sort of avoid getting a lot of issues with water damage. A lot of more high current, high voltage stuff, they're the ones that will normally then get the sort of the worst damage and sort of corrosion. So I'm pretty sure this guy's going to be okay. We'll get him out the way. We need to remember him, we don't lose him. Why don't we yeah, we might as well grab this EEPROM as well at the same time. So we'll just get this EEPROM out now. I'm doing this with the wrong hands and the wrong order. Well, there we go. One EEPROM. So that's the two important bits now that we've got. Our flash memory chip, which has the tuning and all the other bits and pieces on, and the EEPROM. Well, we just need to get these now into another ECU, and that's it. So this guy here is the one that's going to be our donor. So as you can see, E46 BDM OK, that's our type of chip. So I just note this stuff down. This one is not working because the K line, which is the main diagnostics that this uses, is bad, but the rest of the stuff, the processor, the pads and so on, they're all fine. So I've marked this down as something I can use to solder on one of these chips, M58BW016DB, and solder it onto there, use the BDM to read the contents of the memory, and then that can then go into our other ECU through the BDM ports that we've seen on the other side. So he's there now on our BDM rig. We have our power switched on. Now in this case, when I switched him on, I could see the amp draw increase a little bit, showing it's doing something. We will come over now back to FG Tech, and we'll click connect, and will we find anything? Nope. Right, let me try and just reset those pins a little better. Okay, after a bit of wiggling around and just making sure that we're getting good contacts on the pins, we have managed to communicate. So it then pulls out some details here. In fact, we haven't got external flash, so what I'll need to do is give that a bit of a clean up and see if that will show up. So there's our issue. This little leg on our chip not soldered down. So yeah, that's the thing. All of these legs, they're not there for fun, they're not optional. So get a bit of solder on him and we'll go for another read again. Okay, and take two then, with our chip soldered down. We have our lights, we have our camera, and we have action, as we've got everything we need. So now, there was the first time it picked up the processor. It believed that there should have been an EEPROM there somewhere. It's a very unusual EEPROM isn't lit up. I think it's maybe there's various stuff, because I'm trying to go into this as an EDC16. This is an ME9. It might be picking that up as a virtual EEPROM, but whatever. Second attempt there now with the soldering. Processor detected, EEPROM, but we do have our flash being picked up. So what we'll do now is I'll read that flash memory. I'm going to save him, and I'm just going to check that and just make sure all I read is good, and that then is fine then to load into our donor ECU as well as the EEPROM file, and then it should be all ready to go. Well, in fact, no, we're not, because we just had error read pop up. So we do have an issue there. So we do have something to look at. Well, I did it again over here. Can I get this in? Another leg. Another one there in the corner, forgot. So that's probably going to be an address line or something along those lines. These ones, they all seem okay. I'll just give them a little poke as I go along. I'll make sure they don't wiggle. Trying to stab myself or anyone else. So yeah, I would say, imagine he got through reading some stuff and then thought, whatever this one was doing, no good. So add a little dab of solder onto that, and then we'll give it another go. And there we go. Job done. So yeah, 33.3% of the time, it works all the time. I guess this just goes to show you, one of the things that I do like is finding a smoking gun. When you've got a problem, you want to come across something obvious that is generally wrong. Something you can see is like, right, that would cause the issue you've got. Now, I thought that with the first leg, but just because you find one problem doesn't mean that there's not going to be others. So yeah, that's a little mistake on my half, but as I said, we are going to be checking all this data to make sure it's all valid before we stick it into something else. So reading completed, we have the file. Final thing now is I'm going to take a read and a backup of our EEPROM, and then we need to sort out a spare ECU. Well, remember how the phrase goes, fourth time's the charm, I believe was the famous version. So after reading it out of our E46 one, the data was pretty garbled. So what was happening there was the address lines are moved around between the two chips. So something like that would probably do for cloning them, but not for reading out the data the way that we should. So what I've done is I found another ECU. This is him here. Another EDC16 with the same kind of memory chip that we got. BDM okay, but again this one, no communication on the K line. So it's another one that I keep around is dead. This one's obviously closer. Our actual ECU is a CP35. The extra P is for piezo, as it's one of the ones with the piezo injectors. This ECU, non-piezo, so ever so slightly different, but read the data out of it with it soldered into that one, and yep, that all matches up and shows it, and everything I can see all looking good. So that's it, we have that one backed up. Final thing now is our little EEPROM. There he is there. He's going to get lost any minute, so I'm going to read a copy of him and make sure we save him. And we're done. So there is our 95640 chip. That's our EEPROM. Stick it in that TL866XG ECU, whatever. And there we go. We've read it out. There's our data. If I can, where's that mouse cursor? There it is. So we've got some date codes there at the top and some ECU part numbers. So we know then that this is going to be fine. Our immobilizer code, I'm sure some of these rolling codes are built into those bits there. But that's it. Other bits and pieces in there. There's lots of all sorts of stuff. VIN number's going to be hiding in there as well somewhere. But that's it really. So we've got all of our stuff backed up, and that's ready now just for another ECU, and then we'll stick that data in, and that's it, done. Welcome back, to me at least, as we are half a week in the future. What you seen before was Friday, and now we're on Wednesday. This beautiful pink item here is our new ECU. So the first thing I want to do is check that he works before I go any further. So I have him connected up to Flex through on my Flex breakout lead input cable and so on. So now what we want to do is go in and just check. Oh, hang on, we want to switch this thing on first. Nice and musical. There we go. Right, and it is a 6-cylinder Bosch. Let me pump the brightness up to stop the lines. DD6. And that means it's in. You'll often get these messages on input, don't worry about them. Just click them straight through. That's it, this is all working. So now we've got to go over onto Flex, and we'll get Flex then to load the software in. Well, that's Flex now connected into it rather than the breakout lead and into our program. So if you haven't used it before, this is through the bench mode, and here's the obvious question that some of you might ask. It does give you all of these pinouts. So our main, power, ground, switched ignition, that's going to be the K line, and then our 2 other clever wires. So it tells you all where to do all the connections. It's going to be the same connections just to talk to it through input and any other bits and pieces as it is for this. So the first thing to do, we will make a connection to almost sort of log into the ECU in a way, and then what we're going to do is do a full backup, just so we have everything stored as the equivalent of like a save point. So it's going through there now, finding all the various sections that we've got, and there it is. So we have all our bits and pieces. So you can read internal flash, which is the processor, external flash, which is our flash memory, the one that we unsoldered earlier on. External EEPROM was the EEPROM we unsoldered as well. But what we're just going to do now is the full backup. So backup all done, and that's saved, not going to be needing that. So I'm going to go here for a write. So external flash, we picked that, and that is just going to write that in now. So the backup only took just over a minute to do the whole lot, and our external flash now should be pretty quick as well. So there's 39 sectors in there. It's going to go through the whole bunch of them. All of them, I believe, are programmable in this kind of ECU. Sometimes you will come across tri-core stuff, and there will be areas that are like one-time programmable, but this should be all good. So we're going to write in our external flash and our external EEPROM. So all written back into input now for a final check, and DDE6, there we go. Read faults again. ECU service not supported. Right, so that tells us then we do have an issue there in copying that stuff over. Yeah, we do. Right, okay, so I'll need to look into that, because I believe what's happened there is we might have a different file on the processor. And that there is going to be our problem. So the new ECU came from an X3. So that is something I've mentioned before, is the internal file in the processor does have different data in it for an X3, as an X3 would be communicating through to a lot older electronics. So although it's the same ECU, it's got different communication speeds for bits and pieces, so it's not talking the way it should do. I did verify the files, the external flash and the EEPROM, they all programmed in fine, but our issue here is we have a mismatch between X3 generation electronics and E90, which is what we want. So I'm just writing the backup back on. That's always a good reason to keep a backup. And let's have a look through. Yep, he's just finished writing the backup back on. I'm going to double check that now and make sure that works. And looks like what we'll need to do is change the file in the processor. So can be a bit tricky. We'll give it a shot with this. There's our internal flash button, but sometimes it doesn't quite write the internal flash properly. I've had issues like that before, so we'll give it a shot and see what we can do. Now I'll need to find an internal flash that's going to be suitable for this, as obviously our original ECU over here falling to bits. Our memory is inside of there and we can't get into him because our BDM port is gone. We managed to unsolder our EEPROM and we're in on that. We unsoldered our flash memory. We've got a copy of the flash memory, but we're stuck for our memory that's inside the processor. So we need an E90 spec processor file, not an E83 X3 file. It's getting late, but I'm still here. We're 10 o'clock now at night. I still want to get this done. So I tried just putting the flash file alone into the ECU, and after doing that, just the flash file, it still won't communicate. So I think I've come across this stuff before, and it's a mismatch between some kind of configuration and various different processor files. So what I'm doing right now is programming it up with WinKFP and our INPA lead. That one has the eDiabaslib firmware on it. I don't think it's particularly needed for this, although trying to program it earlier, it did come up with the protocol going to be B&W fast and said it wasn't connecting. So I changed the protocol, the communication protocol, to KWP 2000, and it is writing in now. It's slow, but it's getting there. So I found out that the file that is on the 335D, I have a copy of that out of the B&W SP Dayton. I think it was out of the V52, an older version. So what I'm doing is I'm getting the X3 ECU and I'm updating it to the same 335D version. And what I'm going to do then is have a look at that once I've copied that over and see what that's doing. Once that's on, I'll have another go with communication, see if it still communicates, and we're one step closer that we now have the right software on there. But there are still going to be other stuff missing, which is immobilizer codes, injector codes, and so on, and maybe even something to do with configuration. But we're just going to do it in steps now until we find out where things start playing up. Right, it's come to the final stages now of the programming. It was done in 2 stages. I think that's program area and data area. It's just in the data area now. And we should get a little pop-up box any second. Should come up and say programming okay. Please come up. There it is. Okay. Programming okay. Right, so now we'll have a look in INPA and see what it's doing. Right, so back into INPA, DDE6, and that came up before. Now, faults. Will it read the faults? Yes, it does. Right, okay, so previously that's where it was sticking. It wouldn't read the fault. So now we have it on standard software, and with we have the wrong immobilizer code and wrong injector codes in, and we don't have the tuning on there, but we're getting it there, steps and steps closer. So now I'm going to copy over the tuning, and we'll get that on there, and then we'll double check and see how that's doing. So let me just shut this down. Okay, and now writing the file with tuning on into it. So what I've done is read what was on there, which again was a standard BMW file. Go to the tuned one, which was based on this version. That way I can see exactly which bits have changed. Copied those over. So that is done. Our VIN numbers are done as well. Our VIN number, at least for part of it, is that is written into the flash, but there is also some stuff in the EEPROM. So next thing we've got to do is write the EEPROM in, which is going to have all our immobilizer stuff, and again fault codes and injector codes and that kind of stuff, and give that a check and see if that will run. So we're into the big reveal. This will be as much a surprise for you as it will be for me. Yep, we expect that. Faults. Do we read faults? We do. Okay, and now ID. And yep, you can see there, that's from my programming that we've just done with the date and so on. We have our VIN numbers are correct. They were hiding there underneath the blur. And I wonder what else we can have a look at. Somewhere in here there should be injector codes. There we go, and there's our injector codes. So yeah, that should now, let me just have a look through these faults and see what they are. Again, rail pressure, valve, pedal, coolant, boost, bypass, wastegate valve, throttle control, throttle, boost pressure, another boost pressure control, air mass meter. So that is all looking good. So we should call that now job done. And there we go. Now certainly I'm glad that that's done. That was quite the mission to sort that one out. It gets trickier when you are trying to do stuff like save the remap, save the immobilizer code, save the rolling immobilizer code. So this thing is just plug and play. You could disable the immobilizer, but handier to keep it on. Obviously then there's things like injector codes as well. So all saved through and into the new one is all responding exactly the way it should. So that's all good. So yeah, a bit of a mystery then about the whole why it wouldn't take the file with the originally as I wrote it in, taken directly out the other chip. But I have come across that before, and it always seems to be on X3s and Z4s. They always seem to play up with communication stuff, and I know they talk on different CAN bus speeds because they don't have the same stuff you'd have on E90s and E60s, which is the whole JBBE or the body module that you'd have on the E60s, which acts as a CAN hub. On X3s and Z3s, the only thing there that can act as a CAN hub is the dashboard. So your diagnostics got to go K-line into the dashboard. The dashboard's got to translate it into CAN and then push it CAN into the engine ECU. So it does make things a little bit trickier, and the programming can be slower. But yeah, there we go. We have a job done, and certainly I'm glad that it's done now, because it is 11:15 now at night, and it's a pretty chilly night to be out here. But we're all done. Time to get it boxed up, and then this thing can be sent off back to the customer, and that's it. We're out of here. Well, thanks very much for being with us on this magical journey that we've been on here. Hopefully you've learnt a bit. I probably have as well. And I'll catch you on the next one.